Let's trace the blood pressure from the ventricle through the entire body and back to the right atrium. The blood pressure in the left ventricle is the highest in the entire body. From the left ventricle, blood flows into the aorta. So the next highest blood pressure we will see is in the aorta. The blood pressure in the large arteries is lower than the blood pressure in the aorta. So these are the large arteries. Next in line are the arterioles, or the small arteries and arterioles. The small arteries and arterioles will have lower blood pressure than the large arteries. The next in line are the capillaries. The capillaries have a blood pressure that is much lower than in the arterioles. So there's the capillary. Blood pressure here is much lower than in the arterioles. There is quite a huge pressure difference, so the pressure gradient is high there. The next in line are the venules. The venules have a lower blood pressure than the capillaries. Next are the medium-sized veins. The veins have a blood pressure that is lower than the venules. Then we have the really large veins ending up in the inferior vena cava, where the blood pressure is even lower. Finally, we reach the right atrium because the vena cava open into the right atrium and the blood pressure in the right atrium is the lowest in the entire body. Notice how the blood pressure decreases starting from the left ventricle all the way down to the right atrium. This way, the blood keeps flowing down the pressure gradients. If you remember, there are two major factors that affect blood pressure. They are blood volume and peripheral resistance. When these two factors increase, blood pressure increases as well. The sympathetic stimulation increases both these factors and thereby it increases blood pressure. So let's take a look at what happens in an emergency situation or when you are exercising. The sympathetic stimulation increases. So there is the up arrow, increases. It activates the arteriole and the heart. So there's the arteriole and there's the heart. It has a positive effect on both, so we'll put the positive sign there for the arteriole and for the heart. When it acts on the blood vessels or the arterioles, it causes vasoconstriction. We must remember that the sympathetic stimulation, when it acts on the arterioles, it causes vasoconstriction in all the blood vessels that are present in the abdominal region of the body. That's where most of our blood vessels are present. So when vasoconstriction increases there, it increases peripheral resistance in general. So that increases blood pressure. Now the effect on the heart. We know that sympathetic stimulation raises the heart rate. There's your up arrow showing that heart rate goes up. When the heart rate goes up, the cardiac output increases as well. When cardiac output increases, blood volume increases as well. When blood volume increases, blood pressure increases as well. There is another way in which the blood volume increases, and that is via contractility. If you remember, sympathetic stimulation increases the contractility in the heart muscle. So when contractility increases, stroke volume increases. There's the up arrow for stroke volume. And when stroke volume increases, cardiac output increases, which increases blood volume and increases blood pressure. As we can see, two major factors: when peripheral resistance increases and blood volume increase, blood pressure increases as well. The opposite happens with the parasympathetic stimulation. You may have experienced that your blood pressure goes down when you are in meditation or when you're sleeping or doing breathing exercises. So let's see how that happens. When the parasympathetic stimulation increases, it affects both the arterioles and the heart. So the parasympathetic stimulation increases. There's the arteriole, and here's the heart. It has a negative effect on both. On the arteriole, it causes vasoconstriction to go down, which means that majority of the blood vessels that are in the abdominal region dilate. So when vasoconstriction goes down, peripheral resistance goes down as well. When the overall peripheral resistance goes down, blood pressure goes down as well. Now for the heart. The parasympathetic stimulation lowers the heart rate. It does not have much effect on the contractility, but it does lower the heart rate. When the heart rate goes down, the cardiac output goes down as well. When the cardiac output decreases, blood volume decreases. When blood volume decreases, blood pressure decreases. So there we have it again. Peripheral resistance and blood volume influencing blood pressure. Imagine that you're sitting on the floor for a long period of time and you have to get up suddenly. How do you feel? You may experience a momentary lightheadedness. Things may go dark for a second, and hopefully you don't faint and you recover. What's going on here? So here we have it. You're sitting on the floor and you get up suddenly. You experience lightheadedness. A head rush is what we call it. And then hopefully you recover without having to faint. So what's happening? When you get up suddenly, there is also a sudden drop in blood pressure. You remember, you need blood pressure to send blood to the head. So when there is a sudden drop in blood pressure, less blood is flowing to the head, causing you to experience the head rush. The body recovers quickly by raising the blood pressure and taking it back to normal. Let's look at this in detail using a flow chart. You stand up suddenly. Blood rushes to your legs. So the blood flow to the legs, to your extremities, increases. And this causes blood volume to go down. So when blood volume decreases, blood pressure decreases as well. There is not enough pressure to pump sufficient amount of blood to the head momentarily, just for several seconds. This causes a head rush or a feeling of lightheadedness. Let's use a flowchart to see how the recovery happens. When the blood pressure goes down, it is sensed by baroreceptors in the aorta and the common carotid artery. The word baro means pressure. So these are pressure receptors in the aorta, which is your very large artery, and the common carotid, which is taking blood to your brain. They sense that there has been a drop in blood pressure. So they are activated. These receptors are activated. And they in turn send messages to the medulla oblongata, which gets activated as well. That's why you see the plus sign. It means activated. The medulla oblongata activates the sympathetic nervous system. So there's your plus sign again, saying that the sympathetic nervous system has been activated. We know that the sympathetic nervous system acts on both the arteriole and the heart. They have positive effects on both. It is a quick action that is the result of the sympathetic nervous system. It causes a quick vasoconstriction, a sudden vasoconstriction, which increases peripheral resistance. When peripheral resistance goes up, blood pressure goes up as well. And all this happens very quickly in a matter of seconds. Now for the heart, it only has an effect on the heart rate, not that much on contractility. The heart rate goes up momentarily, and when the heart rate goes up, cardiac output goes up as well. There's a quick increase in blood volume. When blood volume increases, blood pressure increases as well. So all this happens very quickly, and the recovery is swift, and blood pressure goes back to normal. We have just looked at how the nervous system profoundly affects blood pressure. Now we will look at how hormones affect blood pressure. We'll start with angiotensin II. Angiotensin II raises blood pressure. It increases vasoconstriction and increases thirst. When vasoconstriction goes up, we know that peripheral resistance goes up as well. PR stands for peripheral resistance. And when peripheral resistance increases, blood pressure increases as well. We use BP for blood pressure. When thirst increases, we tend to drink more water, and this increases water gain. So the body gains more water. And when that happens, blood volume goes up. We'll say BV for blood volume. And when BV goes up, blood pressure goes up as well. So here we have both factors going up, peripheral resistance and blood volume raising blood pressure. Here's the next hormone, ADH, Antidiuretic hormone. The antidiuretic hormone raises blood pressure as well. It increases vasoconstriction and it lowers urination, which means that you pee less. So when vasoconstriction increases, peripheral resistance increases as well. When peripheral resistance increases, blood pressure increases as well. Now for the urination. When you pee less, the water retention increases. You hold back more water. So there is a water gain. Water gain increases. When there is more water, the blood volume is increased as well. When blood volume increases, blood pressure increases as well. So there we have it. Peripheral resistance goes up, blood volume goes up, so blood pressure goes up as well. The third hormone is aldosterone. Aldosterone is a hormone that maintains sodium-potassium balance. So what it does is that it retains sodium and gets rid of potassium. So when it retains sodium, it also retains water. So the water retention goes up, along with the sodium retention. When water retention increases, it increases water gain. So when there's more water, there is more blood volume. Blood volume increases, therefore blood pressure increases as well. Note how this has no effect on peripheral resistance because there is no arterial action going on here. Now let's look at a fourth hormone. This hormone is called atrial natriuretic peptide, ANP for short. This hormone lowers blood pressure. The ANP hormone causes vasodilation. It increases vasodilation. It increases urination. You pee more. This is the exact opposite of what we saw with the ADH. So when vasodilation increases, peripheral resistance goes down. When peripheral resistance decreases, blood pressure decreases as well. When you pee more, there is water loss. So water loss increases. When there is water loss, the blood volume goes down. When blood volume goes down, blood pressure goes down as well. So here we have two down arrows. Peripheral resistance decrease, blood volume decrease, blood pressure decreases as well. The last hormone we will look at is adrenaline. We have already looked at the effects of adrenaline via the sympathetic nervous system. So we can look at it one more time. Adrenaline raises blood pressure. It raises blood pressure by acting on the arteriole and the heart. It increases vasoconstriction, and adrenaline increases heart rate and contractility. It does both. So the force of contraction increases and the heart rate increases. When vasoconstriction increases, peripheral resistance increases as well. When peripheral resistance increases, blood pressure increases as well. With the heart rate and contractility, we end up increasing cardiac output. When cardiac output increases, you increase blood volume. So we are basically increasing blood volume. When you increase blood volume, blood pressure goes up as well. So here again we have blood volume goes up, peripheral resistance goes up, so blood pressure goes up as well. Let's compare blood flow while you're at rest versus while you are exercising. When you are at rest, your body is under the parasympathetic influence, and so more blood flows to the abdominal region. There is vasodilation of the abdominal blood vessels and vasoconstriction of blood vessels going to the arms and legs. When you are exercising, it's the opposite. You need more blood to flow to the arms and legs and less blood to flow to your abdominal region. During exercise, your body is under the influence of the sympathetic nervous system, which causes vasodilation of blood vessels going to the arms and legs and vasoconstriction of blood vessels going to your abdominal regions. So less blood flows to your digestive organs under the influence of the sympathetic nervous system. So digestion is much better when you're resting under the parasympathetic influence, and not as good while you're exercising because less blood flows to the digestive organs. This is why you're not supposed to exercise vigorously after a large meal.